Hi, everybody. Good morning, good afternoon, and good evening, wherever you might be. I am Mickey Gousset. I am a DevOps architect with the DevOps Fast Track team, and we're here this morning to talk about getting started with GitHub Actions. Feel free to tweet along with the show if you feel like it. Now, what we're going to cover today is, honestly, GitHub Actions. I've got some slides that I'm going to start with to level set and make sure we're kind of all on the same page. And then we're going to show you, honestly, a bunch of different GitHub workflows using GitHub Actions. Now, my assumptions going into this talk are either you haven't used GitHub Actions at all, or you might kind of know what they are, but you haven't used them that much. Maybe you've used another workflow type system. So we're going to start kind of bare bones and work our way up. Now, Damian Brady, one of my cohorts, is giving another talk on GitHub Actions tomorrow, where he is going to be doing a lot of different types of things, not just CI/CD, but showing you all the different power that GitHub Actions has as well. So it should complement this talk really well. So feel free to go check out his talk tomorrow at the same time. But we're going to kind of start small and build our way up to where we're ultimately going to end up deploying a web app to Azure. It's kind of the goal. Plus, we're going to do a couple of fun things as well. The most you have to ask yourself is the following, which is, do you know what Tupelo, Mississippi in the United States is world famous for? This is where I live. We're a small 30,000 person town in Northeast Mississippi, and we get about 10,000 people a year that come to my town, probably half of which come from Europe. Well, before you can Google it, I will tell you, we are the birthplace of Elvis Presley. So Elvis Presley was born in a 2-room, not a 2-bedroom, but a 2-room house. So it has a bedroom and a kitchen. So people come, they tour his house, they tour his church, they go to the museum, they go to the hardware store downtown where he bought his first guitar at age 9. Still a hardware store, still owned by the Booth family that sold him that guitar. And then people drive about an hour north to Memphis, Tennessee to see where he lived when he got famous. So that's Tupelo's small town claim to fame, but we're actually here to talk about actions. Now, I've got a fully packed hour of stuff I want to show you. So what I would like to encourage you to do is if you have questions, please put them in the chat window, or feel free to save them up and hit me up afterwards on Slack or on Twitter or on email. I'll provide you all that information, and I will get those questions answered for you. So please, don't lose your question. Just put it in wherever medium you want to put it, and I'll get it answered. If I don't have the ability to answer it because you put it in the chat window in the meeting today, I will make sure I grab those questions and answer them for you. But you're welcome to find me on Slack or any other communication. Now, I mentioned to you that I work for GitHub. GitHub is the largest developer platform on earth. For those of you that may not know what GitHub is, so we've got 50 million developers on it. The top 1,000 open source communities are on it. Over 1 billion contributions are made per year to repos. So it's really, we do a lot of good stuff. And our vision is to try to help people, build their software, and we can do that through, giving them a good place to store their code, giving them access to good workflow tools that can do CI/CD and beyond, the ability to shift left in security and provide security earlier in the process. So we got all that stuff going for us. I encourage you, if you haven't looked at it before we jump into Actions itself, is to go look at our State of the Octaverse report. This is our take on DevOps. So if you go to octaverse.github.com, we've got 3 different reports you can download that cover a lot of cool stuff. Covers actions used. I'm actually going to use some stats from those. Covers all kind of things you might be interested in. Now, I always like to start these talks off, because I am a DevOps architect, with what is DevOps. And a lot of people define DevOps in a lot of different ways. The definition that I tend to use is this one by Donovan Brown, which is DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. And there's a lot of goodness in that statement. Continuous delivery of value to our end users. How do we get, what the end users need to them? And we do that through people, process, and products. Now, the least important of those is products. And it might be kind of funny that I'm saying that, considering I work for a products company and I'm doing a talk on a product. But there are a lot of products you can use to do DevOps. People and process is the most important, and out of those, people is the most important. If you don't have buy-in from top down on what you're trying to do with your DevOps journey, it's not going to work. But today, we're going to focus on products, and specifically, we're going to talk about GitHub Actions. So GitHub Actions is essentially a workflow system. Now, a lot of times when you hear people talk about GitHub Actions, you're going to hear it in the context of CI/CD, continuous integration, continuous delivery / deployment. And it does that, and it does that pretty well. It's the #1 CI system on GitHub right now. But it also does much more, because it can do more than just CI/CD. It can trigger off of any workflow or any event inside of GitHub. And by triggering off any event inside of GitHub, I can do all kinds of things. So in addition to triggering off pushes or pulls, I can do, trigger off labels being added to an issue or somebody starting a repo. It does CI/CD really, really well. One of the cool things, and one of the demos I'll show you, is you have the ability to do matrix builds. So you can define a job one time and then specify a matrix of parameters, and it will spider that job out to run over all those different parameters. The log streaming logs aspects, you can see what's happening as the build is running. Built-in secret store, so if you're not using, say, Azure Vault or say HashiCorp Vault, you can use our built-in secret store. It does use YAML, so if you're used to using a YAML type syntax, then you should pick that up pretty easy. One of the nice things, though, is we give you the ability to run these workflows either self-hosted, you can create your own what's called a runner to run these workflows, or we provide you cloud-hosted runners you can use, and we provide you Linux, Mac OS, and Windows. So you have the ability to be able to do your builds over multiple operating systems without having to maintain those things yourself. Support with our GitHub Enterprise Cloud, our cloud version, as well as GitHub Enterprise Server. And we really are any platform, any language, any cloud. So we're going to run on we can do any platform. You can bring in any language you want to GitHub Actions, and we can deploy to any cloud. Now, in the marketplace we have over 6,800 actions or tasks that you can add into these workflows to help you build stuff. You also have the ability to build your own. So you can actually, be able to make this work exactly the way you need it to work. A couple of quick stats why GitHub Actions I get confused whether it's singular or plural, important to you. Especially if you're doing open source, these are a couple of really interesting stats. Open source projects using GitHub Actions merged 34% more pull requests than those that didn't. And open source projects using GitHub Actions decreased the time to merge by 18%. So for projects that used GitHub Actions, the merge time was decreased and the number of merges it did was increased. That right there shows you how GitHub Actions can help, speed along your development process, because you're able to do things such as shift left on quality, have checks that run against your PRs to make sure your code looks good before that code makes it all the way into your main branch. Now, any kind of demos, I want to do a couple of terminology talks just to kind of make sure everyone understands the basic terms I'm going to be using. And then we're going to actually go look at some examples of actions. So GitHub Actions is the product name. And what you do is you build workflows. So these are GitHub Actions workflows. And what the workflows allow you to do is specify the process that you want to happen. Workflows are YAML files, so they are white space sensitive. You have to keep that into account. And they go in a special directory in your GitHub repo. So in the root of your repo, you're going to define a .github folder, and in that folder, you're going to define a workflows folder. And that's where all of your workflow files will go. There's an example workflow file here on the right. And these workflows could do pretty much anything. They can be they can trigger off different events that are happening inside of GitHub. For example, somebody submits a new issue, you could have a workflow that automatically sends them an email saying, hey, welcome to the repo, thank you for the new issue. So workflows are the files we're going to build. Workflows are triggered off events. And those events could be, like I said, a push or a pull to a pull request or a particular branch. It could be a schedule, so you have this run once a day. You can use what's called work dispatch event trigger to be able to do a manual workflow. So you just click a button and have these workflows run. Like I said, and the documentation on GitHub Actions is very robust, and there's a lot of different events that we can use to trigger our different GitHub Actions. Now, in addition to being called GitHub Actions as a product, there are also things you add to your workflows, which are called actions. And actions are, think of them as tasks, they're reusable code that can be used by your different workflow files. And these actions can be, you can build your own action, you can go out to the marketplace and get actions. Usually they're built using either Node.js, or they can be run in a container using any language. Some examples of actions that we have out there that a lot of people use are like, there's a stale action. So you can scan your repo for issues and pull requests that haven't been touched in a while. There's an Azure Web App Action. If you want to be able to deploy that to, say, an Azure Web App, we're going to use that one today. Then there's an action there that we can use to be able to deploy out. And it just kind of encapsulates what actually has to happen, and you just provide some parameters and it works. And like I said, a lot more actions out there on the GitHub Action Marketplace. The nice thing about all these actions is the code is also available to you to look at. So you can go to the repo where the action was defined and see exactly how the action works if you want to dive into the code. Obviously, what you don't want to do is be personal access tokens or logins into your source code directly, so you need to be storing those in a secret. Secrets, you should be using, say, Azure Vault to be able to store your secrets, but GitHub also provides you the ability to store secrets, and at multiple levels. You can store them at the organization so that all your repos or some of your repos can access those secrets. You can store them at the repository level so that all the workflows in a repository can access those secrets, or you could store them in a repository environment level. So something new that we just released in beta in December is the ability to define environments. And that allows me to specify secrets that only apply to that particular environment. Speaking of environment, it's currently in beta. So if you're using environments, you can define, say, a dev environment or a QA environment or a production environment. And then you can take the jobs in your workflow and target those environments. And when you target a job at an environment, you can define rules such as required reviewers, people that have to approve the job before it can run, or wait time. It has to wait a certain amount of time before it can run. And you can define environment level secrets. For example, you may have different Azure keys or AWS keys for accessing dev than you do accessing prod. And you can define those keys in those specific environments, but only jobs that target those environments can use those keys. Now you have a way to obviously run these workflows, and that's what runners do. You have both hosted runners, which GitHub maintains for you up in the cloud. We have Linux, Windows, and Mac runners. We maintain those. We make sure they're upgraded. They come with pre-installed software, most of the things you might need to be able to do your builds or do your deploys. You can also use these free if you're using public repos, which is really nice for open source projects. And of course, the software that we use for these runners is open source. You can go out to the Actions Runner repo and actually see that software. But some companies want to run their own runners. They don't want hosted ones. So therefore, we provide a self-hosted option. You can spin up your own VM, install the runner software, and then you're able to maintain that VM with what it needs for your builds. It could be you need to do this because you need to keep everything behind your firewall. It could be you have certain third-party tools that need to be installed for your builds to work. So you do have that option of having self-hosted runners as opposed to cloud runners. And of course, you can build your own actions. So write the actions either in JavaScript or using a container, using any language you want. JavaScript is usually faster and sometimes provides a little bit better user experience, but we try to be versatile to let people build their actions, and what's going to be best for them. So that's enough terminology. Let's actually look at some of this stuff. Multiple demos, and we're going to start off with your classic hello world, because why not? Then we do what I like to call the hello world matrix style demo. Each of these demos is going to build off of the other one. The next demo after that, I like to call the Oprah demo, because you get a job, everybody gets a job. And fourth demo in this first section is going to be about context and the context objects that are out there, specifically the GitHub context object, and how you can drill down into that object to get a better understanding of the information that's there for you. So with that, let's jump over to my code. So I have created a repo here for us to use. And in fact, you go to github.com/Mickey Gousset/NDC London 2021. It's a public repo. It's got all the workflows that I'm using out there. You're welcome to check it out if you'd like, but that's the repo I'm going to be using today. Here we are in the start of my repo. Now, if you're just getting started with Actions and you go to the Actions tab, you're not going to see this. What you're going to see instead is just like a new workflow button, because you haven't created any workflows previously. So if you click the new workflow button, then you get a bunch of pre-made workflow templates. So GitHub tries to guess potentially what you might want to use in your repo, but then we also have all of these pre-made templates for doing different things. So for example, if I was doing a Ruby or Node.js or .NET, then it will prompt me. I can click a button and it will pre-create a default template with certain actions in it for me to help me get started. So what I have done for this demo, and I've kept the demos pretty simple for the most part, except for the last couple, is I started with just a manual workflow, and I clicked set up this workflow, and it pre-created a file for me. So if I come back over here to code, I told you all of these workflow files are stored in a .github Workflows folder. So if I go into that folder, I can see all my different workflow files that I've created. And if I go into demo 1, this is my basic workflow, right? Super simple. And if we look at this workflow, we can see that the bare bone, we have a display name. So obviously demo 1, that makes sense. Then we have the trigger. This is what triggers the workflow, the keyword on. So you have the keyword on, and then you specify the different events that could trigger this workflow. And you can have multiple events that trigger this workflow. In this case, I've only got one. I'm using workflow dispatch. This allows me to just manually run this workflow when I want to run it. You can also ask for inputs. So I'm actually prompting the user for an input that I'm giving a variable name called name, and I'm going to give a default value. I can make it required or not. So when I manually run this, I'm going to ask the user to give me a value, and I can use that as part of the workflow itself. In your workflows, you define jobs. The jobs are what get stuff done. Each job defined in your workflow runs on its own runner. So if I have two jobs, I have one job running in this runner, one running in this runner. They don't talk to each other. So because what happens is I spin up a runner, I run that job, then I destroy that runner if I'm using cloud hosted. So you have to take into account if you have a runner or a job that needs information from another job, you have to figure out how you're going to get that information, share that information between the jobs. But in this case, I have only one job. I named it greet, so you can name your jobs whatever you want to name them. I just named it greet. I specify where that job runs using the runs on command. And the runs on allows me to specify either, in this case, I'm specifying Ubuntu-latest, which says use the latest version of Ubuntu that we have that's cloud hosted. If you have, we also have this for Windows, we have this for Mac. If using self-hosted runners, then you would have installed those and created a group, and you can then access, you would put that group name here, and then you could access those self-hosted runners. So a job, we have it run on something, and then the job is made up of a series of steps. And these steps are the actions, the tasks that you want to take in this job. A job can have one step, it can have multiple steps. In this case, I have only one step. I gave it a name, send greeting. And all this step is doing is a run command. And what a run command does is it runs a single line or a series of lines in whatever the shell script is of the runner that you're using. In this case, I'm using Ubuntu, so it's going to use bash. I'm just doing an echo. If I was using Windows, it would be using PowerShell. This echo is doing is it's saying echo, and I want to echo out the name provided to me when I run this. And I access that name by accessing the GitHub context variable and drilling down into that variable to find the name variable that we passed in. And when you want to access content from a variable, you use $, curly brace, the variable name, then curly brace, curly brace. So this works. If I wanted to edit this, I have two options. It's a file in my repo, so I could download the repo, I could modify it in VS Code. However, if I do edit my workflow files in the browser, I get this little workflow editor. And a couple of nice things about the workflow editor, it's intelligence. So I have the capability, it will try to help me figure out what I can and can't type in a certain spot, as well as access to the marketplace. So let's say I wanted to add a deploy to an Azure Web App here. I could do a search for, say, Azure Web, and there's the Azure Web App. I can now see the YAML that I need to add. So it helps me determine, I can cut and paste this, then modify the appropriate items. I can also go directly to the marketplace listing for this if I want to see more information about this, about the workflow. And I can even go to the repo and see the code that makes up this particular action. So how do I run this thing though? To actually run this thing, we're going to go to Actions, and we'll go to Demo 1. And because this is a workflow dispatch action, or is looking for the workflow dispatch event, I have a Run Workflow button here. So I can click Workflow. I can run this workflow off of a particular branch if I want to. And here you can see it's prompting me to enter a greeting. So I'm going to say Run Workflow. And you can see the workflow started, so I can click in. I can actually watch this run. Now this is boring, it's not going to do anything fancy, it's going to run pretty quick. But what we can see is we've got some visualization that allows us to see the different jobs that are defined in this particular workflow. In this case, we just had our one greet job. I could drill into that greet job and can see each of the different steps. Here's the send greeting step where it wrote out hello world. That basic information around, total, how long it took, whether it was successful or failed, and if I had any output artifacts that I put into this, all of which we're going to do in just a little bit. So that's my basic hello world, get you started, introduce to the concepts. So if we go back to my code, let's spice it up a little bit. A lot of times when you're building software, you want to be able to test it on multiple operating, or you want to be able to do things on multiple operating systems and potentially multiple versions of a framework. Now, I could create a job for every operating system I want to test on and every version of a framework I want to test on, duplicate a bunch of steps and make it work that way. But we give you the capability in GitHub Actions to use what's called a matrix to define that. You can define the once and have it run multiple times over multiple parameters. Now, this demo is the same kind of demo. That's the name, has the on workflow dispatch event. But if we look at the job definition, that's where things get a little bit different. I've my job, I still called it greet. That's the name of the job. But now I've added this section. And what this section does is it adds a matrix strategy to my job, to my greet job. So under the matrix keyword, I define multiple items. In this case right now, I've only got defined a variable called OS, and I have 3 different values. These are the Ubuntu latest, Mac OS latest, and Windows latest, which are the runners in the cloud. So what I want to do is take this one job and run it over all 3 of those operating systems. So rather, and again, all this job does is echo out hello, whatever the name is. But the key here is I'm able to take this job, and let's go grab demo 2. The key is I'm able to take this job and I'm able to define the job once. See, can run it over multiple operating systems. So you'll see it says matrix greet. So it's showing you that you're using a matrix. That's important. And it's going to run all 3 jobs in parallel. So I can't, depending on your plan that you have with GitHub, you get X amount of jobs that can run at the same time. So in this case, you see it ran all 3 in parallel over the 3 different operating systems. Now, if I come back to this workflow and I'll go and edit it, and I add in a second aspect to this matrix. So in addition to running over all of these operating systems, I want to run over all of these versions of Python. I want to run all of the different combinations. So think on the map. I've got 3 operating systems and 3 versions of Python that I want this job to run over, and I've only defined this job once. So if I commit this job, change, and then I come back out to my actions, go to demo 2, and start this flow, how many jobs do you think it's going to spin up? You can see it spun up 9. Again, I have that one job, but because I've defined the matrix, it will run over all of those different parameters. And this is really good if you're building an open source component or a component that you need to test on, say, multiple versions of Node or multiple versions of Python or multiple versions of an operating system. You obviously have to make sure you've written your job so that it will work on all of those, not use anything that's, say, language specific to a particular environment. But it makes it very easy to be able to maximize your workflow that you've written. So that's our hello world. We've showed you hello world matrix where it stands out the jobs for us. Now let's just look at an example of a workflow that has multiple jobs in it and how you can actually have jobs rely on other jobs. So this takes us to demo 3, and with demo 3, same thing as before. My name, got my event workflow dispatch, but now we're defining multiple jobs. So we're going to define job 1, it's going to run on Ubuntu and it writes job 1. We're going to define job 2 that just writes out job 2. And we're going to define job 3 that just writes out job 3. So we just defined 3 separate jobs in our workflow environment. Previously, we defined one job and then we spanned it with matrices. Now we're defining 3 separate jobs. And come here and go to demo 3 and run this workflow. Then a couple small changes that you'll see that's different from the matrix. 3 jobs still will run at the same time. The difference is in the visualization, it no longer says matrix. It shows you the 3 jobs all running at once. And that's just, helps you distinguish between, was this a matrix span out or was this just a 3 jobs running? And of course, with any of these jobs, I can get into them and I can see the specifics around the job run. However, what you're really going to need probably is the ability to string these jobs together in a certain order. And that's what you can do using another keyword. In this case, the keyword is needs. So if you define the needs keyword, you can define a job, multiple jobs that need to complete successfully before this job will run. Now, also you have in GitHub Actions the ability to define conditional statements on jobs or on steps. So I could have like an if statement that says, if the previous job completes successfully and outputs this value, then run this step or run this job. But what the needs statement does is allows us to make sure this job only runs if any of the previous jobs listed run. Let's make some changes to this file. And what we're going to do is job 1 is going to be our first job, so it's just going to run. We're going to tell job, job 2 to only run if job 1 completes successfully. We're going to do the same thing with job 3. Job 3 is going to run only if job 1 completes successfully. So it should be 1, then 2 and 3 running at the same time. And then just because we can, we're going to add in a job 4 here. And 4 is only going to run if both 2 and 3 complete successfully. So let's save this change. And we'll go back over and we'll run job 3 one more time. So we'll go back to our demo, or we'll run demo 3 one more time. Go back to our demo, run this. And now what we should see is visualization has completely changed. We now have job 1 that's running first, followed by job 2 and 3 that will run at the same time, and then followed by job 4 that will run after that. Now I'm using cloud-hosted runners, so they don't always start immediately. Usually they start up within a minute or less, because it has to go out, find a runner, grab it, initialize it, and then you're good to go. So in this case, we're starting our workflow run, and now it found a job and it's finished that fast because our jobs are that slow or that small. You can see we're able to chain these jobs together. Now, a couple of demos from now, I'm going to show you how we can chain these jobs together using environments and using approvals to be able to control the flow. But we do have the ability to make these workflows run in the order that we want them to run in. So we've got our basic hello world. We've talked about jobs. We've talked about steps. We've talked about matrices. We've talked about multiple jobs and defining how you can link those multiple jobs together. One of the things I want to show you, though, and this is a cool little tip that I like, is if you'll remember, when we're accessing the parameter that got passed in, we access it by saying $brace github.event.inputs.name. GitHub is a special context variable that contains all the information around what made this thing trigger. And there are multiple other context variables out there as well. There's some for steps, there's some for workflows, but the GitHub one is the main one that has a lot of information in it. So you can look at the specification in the docs on what you can get out of that GitHub variable, but sometimes you want to actually see what is available to you in a particular run. What I is create this workflow that obviously has a name. We're still triggering on workflow dispatch. Has one job called greet. What I'm going to show you is this step right here. I have added a step, and in this step, what I'm doing is I'm creating an environment variable called GitHub context, and I'm setting that equal to the GitHub context, but I'm converting it to JSON. So I'm going to take that GitHub context variable, I pass it into this function to JSON, and it gives me the JSON representation of that GitHub context. And then I'm going to output that to the command line so that I could actually review it. You'll notice here I've got another step down here where I'm saying I'm actually echoing a build number. A lot of times people want to know a good unique way of creating a build number. Well, one way you can do that is by combining the run ID, which is the unique workflow ID, as well as the run number, which is the number of times it's been run. And you can use that to combine to build a build ID, or at least get started with a build ID. But I want to show you what this output looks like and what you can do with it. So if we come back up here to Actions and we go to Demo 4, and we run this workflow, then this workflow will run relatively quick, and we'll be able to dive in and see what the output of the JSON format looks like for the context. In this case, what it looks like, starting at line 153. And all of this makes up the GitHub context. Lots of URLs to different things, information on the events that triggered the workflow. But I want to point you to, all of this is GitHub. Then we've got event, inputs, name. So where we were writing github.events.inputs.name, that's how we were able to drill down to get to world. And here is the run ID and the run number that I was putting together to try to build a number from. So being able to output and look at the value of a GitHub context during your workflow is also helpful from a debugging standpoint. If you're trying to do a workflow to do a certain thing and it's not working, then you might want to output the context and make sure you're referencing things correctly. All right, so we're in progress. Let's jump on to a set of demos, have a little bit more fun. So we've set the baseline for understanding how these workflows work in general. Now what I want to show you are approvals and environments. So we're going to define 3 environments, a dev environment, a QA environment, and a prod environment. In our dev environment, we're going to have a manual approval, a required reviewer. In our QA environment, we're not going to have anything. In our prod environment, we're going to have a 1-minute wait before it can deploy. Then I'm going to have a demo where we're going to show the basics of being able to apply a workflow to a pull request or to a push to a particular branch. So in this case, we're going to assume we're doing a main branch and feature branch development. We're going to create a PR off of that main branch and have a workflow that would run that would, verify whatever, yes, shift left and quality. If that workflow approves or completes successfully, then we're going to put that branch to main, where then we'll have another workflow that might run. And we're going to show you how you can require that the PR GitHub Action workflow pass in order to be able to do that merge from your PR to main. And we're covering these 2 environments to then to the next demo. We're actually going to do this with an actual application versus all of Mickey's just echo statements. So let's go back over here and go back to code and go to my workflows. And we're going to start off by talking about environments and approvals. So this is new, just opened in beta. And to get to those, you go to settings. And on the left-hand side under settings, you have this section called environment. And you have already pre-created some environments for both my demo 5 and my demo 7. To create a new environment, simply click the new environment button or edit an existing environment. In this case, say my dev 1 for demo 5. I can just click it. And remember, environment is a construct. It is a way to target a job at a particular environment where you can define some rules. The rules you can define right now are required reviewers. So you can specify up to 6 people or teams that are required reviewers. Now, only one person has to say approve or reject. We don't have the ability to require multiple reviewers right now. I'm sure that's coming, but right now it's one person approves it, one person rejects it. Whoever does it first wins. Or require a wait. So you can say you need to wait so long before you deploy into this environment. And that can go from 1 minute all the way up to 30 days. If you do modify these, make sure you click the Save Protection Rules button, because you can click off this page and it won't save them otherwise. And then you can also define environment level secrets. So these are secrets that are only accessible if you have a job that is targeting that environment. Dev environment, I specified, that I have to review this. For my key environment, you could say I haven't specified anything. And for my prod environment, all I've done is give it a wait state of 1 minute. So how do we actually access these environments in our code itself? So if we go look at the demo 5 code, Again, starting to look pretty similar, give it a name. We're still using workflow dispatch for now because we're manually triggering these things. But for job 1, which we want to access the demo dev environment, we use the keyword environment. So you specify the keyword environment, and then you specify the environment name. Fun fact, or just something to be aware of, if you specify an environment name that doesn't exist, when this job runs, it will create it. So keep it in an environment section. So keep that in mind. If you do mistype it or misspell it, it does create it when you run it. And of course, I'm just doing an echo. Now, 2, which is my QA environment. So it targets the QA environment, but it needs job 1 to finish. So I'm going to go into dev, then I'm going to go into QA. For my job 3, I didn't specify any environment, so it's going to run once job 2 finishes. And then for job 4, it needs job 2 to finish, but it also goes into the prod environment as its target. So what I have is the first job targets dev, should require me to approve it. Once it runs, the next job targets QA, should automatically run. Job 3 should run after QA finishes, and then job 4 should run after QA finishes, but it has a 1-minute wait state. So if we go back up to actions and come over to demo 5 and we start demo 5, then we can see that nothing has started yet. Demo 5 dev is waiting for review, and I'm prompted here that I need to review this. Now, if I've set up my account to get notifications, I would have gotten an email. I can also go to github.com/notifications to manage those notifications as well, and I would see the notification there. If you've not looked at github.com/notifications, definitely check it out. It's a great way to manage your GitHub notifications, and I have to do a whole lot of email. But to approve this or review the deployment, I click the Review Deployments button. And I can either approve it or reject it. So I'm going to say, I approve this. And I'm going to say approve and deploy. And this will start the workflow running. Now you can see down below, it shows you who approved it or who rejected it and what they said. And what we should see is job 1's going to run. You can see it's deploying to demo 5 dev. Then job 2 is going to run. It's going to deploy to QA. Then 3 and 4 are going to run, but 4 is going to have a wait state, and we should see it's even going to start a little timer to count down for us how long we have before it will deploy for job 4. So you can see we've got a timer there. The timer is slowly starting to count down, and when it hits 0, then it will, in this case, deploy to job 4 because that's what we've specified. The nice thing about using stages is if you go back over to your code tab, we also have an environment section on your code tab. So you can see in your different environments what's been deployed and how it's been deployed. So for example, I can change this change my view to say demo 5 dev. And I can see all the deployments that have happened at demo 5 dev, including the commit hash to be able to tie it back to the code change that might be in there. So you do have the ability to see environments and see what's been deployed to those environments while this stuff is happening. Now, let me come over here. You'll notice that demo 6, they're both disabled. I disabled those on purpose so they wouldn't be triggering while we were doing some of the earlier demos. But I'm going to enable this workflow for demo 6, and I'm going to enable this workflow for demo 6. But you should be aware that you can disable those workflows if you need to, so that if you don't want them running for whatever reason. Now, demo 6 is all about being able to do workflows that run against pull requests, workflows that run on pushes to a branch. So out in the code, this is a workflow that I want to run on a pull request to main. And again, very simple workflow for the most part, but it is not my on statement. But now I'm looking for the event pull request. And then under that event specifically, I'm looking for pull requests made against the main branch. I can define multiple branches. I can define branch paths. I can do a lot of stuff to make this, very targeted, but I just want to target my main branch. So any pull request that's created that targets the main branch is going to run. And this is going to then run a job called PR check. You'll notice I changed the name. And of course, right now, because it's just a simple demo, it's just going to echo out. This will run automatically anytime I create a pull request against the main branch. If we look at the put main, it's a very similar one in that I'm using the put keyword and I'm looking for any pushes to the main branch. So the scenario being, I create a pull request, I run a workflow to verify some stuff. If it looks good, I push that code into my main branch. My main branch then runs a build and deploy. Now, I poorly did not rename the job, still called PR. I should have named it something else, but this is the job that will run on the push to main. Now, by default, if I create a pull request against main, it's going to the fact that I have demo 6 PR workflow out here that's targeting those, and it's going to automatically run, and it will show up as a check on that pull request. The catch is that check required. So the check may pass or the check may fail, but even if the check fails, you could still merge that into master. So it's a good smoke test, but it doesn't necessarily stop you from being able to merge that code into master. If I wanted to stop the code from being able to merge into master if the check fails, that's where I have to use branch protection rules. So if I go under settings and I go to branches, I can find branch protection rules. And in this case, I've created a branch protection rules that it's any branches named Mickey Gousset / demo6 star. You can see it's currently applying to a particular branch I have out there. But for any branches that match pattern, I'm going to require the status checks pass before merging, and I'm even specifically going to require that the specific PR check passes, that specific job passes. So I'm going to require that my PR workflows that I've created pass in order to be able to merge into main. And I can do that using these branch protection rules. In this case, I'm targeting a particular branch. So if I come back out here and we node change, just edit the README, and we'll say this is demo 6, please work. I'll give it a commit message, demo 6, to work. And I'm going to create a new branch for this. So we'll call this branch Mickey Gousset / demo 6-2. And I'm going to propose this change. And what this will do is commit the change to this new branch and let me create a pull request. So yay, create a pull request. And after a moment, we're going to see that this should refresh for us and tell us that we have, there we go. Our PR, our checks haven't completed yet. We can actually click this and go and view the results of the job. We can see it ran successfully, and we can see back our pull request that it ran successfully. We can just drill down and see the checks. And then I can say, okay, let's merge this pull request. Now, merge the pull request over to actions. That obviously kicked off the push to main flow that we have. And so it's going to run successfully. So now I've got the basics of, I have a pull request that has a workflow that's going to run when I create the pull request on that particular branch. We're going to verify that everything works in that workflow before we allow the push to main. And then when we push to main, magic happens and we do a build or we do a deploy. So I've done all of this to introduce you to GitHub Actions, to get you started with them, to then try to actually do something real. So I have taken the most MVC core app there is, which is you just do a .NET Core new and create an MVC app, and using that as my demo. So we're going to basically take demo 6 and do it for real. to deploy this MVC app into Azure. So we're going to create a branch, make a change. We're going to have a workflow that runs that verifies the code will build and deploy appropriately, or that will build and the tests run appropriately. Then we're going to take that PR, approve it, push it to main, where we're going to deploy out to multiple environments into Azure. We're going to deploy to QA at the same time, and then we're going to do a manual deployment or manual approval to deploy into prod. Let's go with that. What I'm going to do is come back over here to Actions, and I'm going to disable my demo 6. You disable a workflow by simply disable workflow. And I'm disabling those so that those don't trigger at the same time as my demo 7. And I'm going to enable the demo 7, which is the actual .NET Core app that we're wanting to do this for. All right, let's go look at those. Now, in my main repo, I have an NDC London folder, and that's got my .NET Core app inside it. If you look at the workflows are going to look similar, but they're actually going to do something. If we look at the PR workflow, what this PR workflow does is we've got a job. Obviously, we're targeting pull request branches to main. We've got a job called build test branch, and we have multiple steps. The steps are setting up the .NET Core environment. They are, it's doing just a .NET restore, .NET build, .NET test. Then we do a .NET publish, which publishes the build outputs to a folder called NDC London app. So this has all the stuff that my web to actually, be able to display my MVC website. But then we have this step, upload build artifact. I'm going to take that NDC app, upload it, that folder, and upload it as an artifact to my workflow, so that then, since this is a PR build, maybe I just want to be able to go view the outputs and be able to verify things manually. So this is going to actually take that build artifact and load it up to the workflow file. That's the PR build or PR workflow. If we look at the push to main workflow, one, we have, in fact, let's go do this though. Before we look at those, just to get some of this stuff started a little bit, let's go make a change. So I'm going to come out under my views, my shared view. I'm going to edit the layout, make a quick change, and we're going to add in just a quick little menu item just because we can, and we'll say NDC is awesome. Commit that to a branch. So we'll call this Gousset / demo 7 - 4, and NDC is awesome. That's my commit message, and we're going to propose that change. And I'm going to create a pull request for that change. So what we should see in just a moment is our PR workflow should run, which does the build, the test, and should ultimately output some stuff for us. Now, if we go back over and look at the workflow that's going to run when we finally push to main, that one, we have a build job, and that build job is very similar to what we had in the PR, right? It does a build, test, publish when we upload the build artifact to this workflow. But now, after that, we have a deploy job, deploy to dev. And deploy to dev is targeting the demo environment and also providing you a URL to that demo environment, which will be a clickable URL that we can click on to go see the results of the deploy. And what we're doing here, though, is we're not doing a build, right? Because best practice is we want to take these build artifacts and move them throughout our different environments. So instead, what we're going to do is download the artifact from the workflow. So in the previous job, uploaded the build artifact to the workflow. Now we're going to download the build artifact from the workflow, and then we're going to deploy it using that Azure Web App. We're going to do the same thing with QA, and we're going to do those after the build app completes. And we're going to deploy to a QA slot as well. And then finally, if QA and dev both complete, we're going to deploy to prod. Same basic code in all three jobs, just targeting different environments and potentially even using different secrets. All right, see that check passed successfully for the PR. If we go look at the details for that, then we can actually see we go to the action for that, sorry, and we go to the demo set PR and that particular run. You have an artifact here, that .ndc build artifacts. We could download that. To back to the request, and let's merge this pull request. And by merging this request, if we go back to actions now and go to push to main, we have that visualization. We can see that it's going to build, that it's going to deploy to both dev and QA, and then it's going to deploy to prod. Now, while that's running, just for fun, if you want to go to the repo, github.com/mickeygousset/2021, and wait till I tell you to, and then start the repo, we can have a little fun. Nothing like incredibly fancy, but I've also created a workflow. You can do more than CI/CD. So if I go to workflows, I created a workflow that uses it looks for the watch event, and specifically of type started. This is an event that is thrown whenever you star a repo. And what this is actually going to do is just going to tweet me. It's actually going to send out a tweet that says, nothing to see here, ignore the man behind the curtain. So if you go and star the mickeygousset.com/NDC London 2021 repo, then if we go look at my Twitter feed in a few minutes, I should see a bunch of these, nothing to see here, ignore the man behind the curtain. So that's just a little fun thing that we can do. Let's go see how our domain is going. Here you can see, this is cool. So now we're deploying to dev and QA. Notice how I have it shows me where I'm deploying, and I have a nice little status bar that shows me, the number of steps that are in this deployment and where I am in this deployment so far. I can actually go into a particular stage and I can see where we are. At this point, we're at the deploy to Azure step. So we're almost getting done. And what will happen once those deploy is then I'll hit a manual approval to deploy to prod. Again, these are all environments that I defined in my environments. But you can see I also provided me a link. So if we open this up, we should see, boom, NDC is awesome. But if we go back to the prod website, it says NDC rocks. So we deployed to those websites with the values that we wanted. And of course, now I can approve this deployment. That will kick off the deployment prod as well. All right, so I'm going to put these slides up. I've got a conference repo. If you go to github.com/mickeygousset, I've got a conferences repo where I put all my slide decks. I'll make sure I put these slides up. Obviously the repo right here with all the examples if you want those. Some quick tips that you might want to be aware of with GitHub Actions. You can also trigger a workflow from, say, a webhook. So if you have something happening in another app and then you wanted to trigger a workflow in GitHub, you can using repository dispatch. You can schedule them. We talked about the need, how you can resolve dependencies. You can have a job run based off of or a step run based off of if something failed. So basically, if it failed, run. If it failed, run. There's all kind of conditional statements I didn't even get into today of how you could specify, only run a job or a step on if certain criteria are met. And of course, you have secrets that you can use as well. Provided you some resources, the Octoverse, link to Awesome Actions repo, which is amazing. It has so many links to so many different action stuff. Highly recommend the Awesome Actions repo. The documentation is also great. If you're not using the GitHub mobile app, I recommend you use the GitHub mobile app as well. And of course, if you want to learn more about Tupelo, Mississippi and Elvis's birthplace, I provided you a link to that. I told you this would take up all the time. I'll check and see if there's anything in the chat to answer. Otherwise, you can hit me up on Slack. You can send me an email. You can send me a tweet. I'll be happy to answer questions. I hope you enjoy the rest of this conference, and I really appreciate you giving me the chance to come out and talk to you about GitHub Actions.